Okay, so this video is about dividing polynomials. Last lesson we learned how to add, subtract, and multiply. Division gets its own lesson because it's special. So just one objective here, dividing polynomials using two different methods. We have long division. It's exactly what it sounds like. Long. And then we have synthetic division, okay, which is not long. Maybe that's what it should be called. Okay, before we get started with the polynomials, though, let's do some old-fashioned division, some old-fashioned long division. We're going to divide 5 into 3,462. Okay, so we know, if we remember correctly, that the 3,462, that's going to go inside the division house, and the 5 is going to go outside of the house. Now, what I want you to do is I want you to stop right now. I want you to pause the video and see if you can remember how to do that yourself. I don't want a decimal at the end. Leave the remainder or turn that remainder into a fraction or something like that, but no decimal. See if you remember how to do that long division. I want you to try to stress your memory to try to do it, because it'll make the polynomial long division much simpler. Okay, so whenever I go to do this long division, I ask myself, how many times does 5 go into 3? Well, it doesn't. So then I ask myself, how many times does 5 go into 34? Well, it goes in there. 34 is almost 7. It would be 6 times, right? So 6. Now what do I do with that 6? I multiply that 6 times the 5, and I get 30. And I put it right underneath the 34, and then I subtract those. Well, there's 4 left over. Then I'm going to bring the 6 straight down, and now I ask myself, how many times does 4 go into 46? Well, that should be 9 times. And then, what do I do with that 9? I multiply. 9 times 5, I get 45, and then I'm going to subtract those. I have 1 left over. Now I bring down the 2. And then one more time I ask myself, how many times does 5 go into 12? It goes in there 2 times. 2. Then I multiply that times the 5, and I get 10, and I subtract them. And that 2 down there at the bottom, that's the remainder, right? If we were doing this with decimals and stuff, we'd put a 0.0 at the end and we'd just keep going. But before you learn how to do decimals, you learn how to put like R2. And then after the R2 for remainder 2, you learn how to turn it into a fraction. And whenever you turn this into a fraction, 2 would be the top number. What would be the bottom number? The 5, what you divided by. Okay, so let me label some parts on this whole thing. Whoa. Get ahead of yourself. Okay, so what I'm dividing by is called the divisor. What I divide into is called the dividend. My answer is called the quotient, and then anything that's left over is the remainder. Okay, so here's what it looks like in terms of the long division. Here's what it looks like in kind of a horizontal line here. If I were to divide 3,462 by 5, 5 is the divisor, so what I'm dividing by. 3,462 is the dividend, what I'm dividing into. 692 is the quotient, that's the answer. The remainder, 2 goes on top, and 5, what I divided by, is the divisor, it goes on the bottom. Okay. Alright, so that is exactly what you do whenever you do polynomial long division. Except for, they're not just going to be numbers, they're going to be polynomials. Okay, so if you're lucky enough to get a remainder of 0 when dividing, then that means your divisor divides evenly into the dividend. Let me go back here. Our remainder was 2. So does 5 divide evenly into 3,462? No, because there was 2 left over. If there was nothing left over, then that means that 5 divides evenly into 3,462. It also means that 5 is a factor of 3,462. But in this case it's not, right? So if you have a remainder of 0, that means it divides evenly. That means that the divisor is a factor of the dividend. What I'm dividing by is a factor of what I'm dividing into, okay? And remember, factors, all factors mean there's just things that you have to multiply in order to get an answer, okay? To get a product. Okay, so here's an example. If I were to divide 3 into 192, I'd have a remainder of 0. This means that 3 divides evenly into 192. It also means that 3 is a factor of 192. since it is a factor, I can multiply 3 times some other number and get 192. Okay? All right, so all of these things are important. These are things that maybe you already knew, but they all apply to polynomial long division as well. Okay, so the first part of our objective here, being able to divide polynomials using long division. So look at this. I'm going to say it's a squash. And how is it being cut? It's being cut lengthwise. It's long division. Anyway, so dividing polynomials works just like the long division that we started this lesson with. In fact, it's called long division. Okay? So before you start your division, though, you want to make sure that your divisor and your dividend are in standard form. So put the thing that goes inside the house in standard form, the thing that goes on the outside of the house, put it in standard form too. Okay? If you are missing any terms, like for example, it skips over x squared, it goes x cubed, no x squared, and then an x, then I need to put a 0 in there as a placeholder. Okay? So here's an example of that. I have 2x cubed plus x plus 3. I'm missing an x squared term. So whenever I do this long division, so that everything lines up properly, I need to put a 0x squared term in its place just as a placeholder. Okay? Okay, so let's try one. I'm going to divide x plus 1 into x squared plus 3x plus 5. The x squared plus 3x plus 5 is the one that's going to go inside the division house. That is my dividend. X plus 1 is my divisor. Okay? So I proceed exactly like I did with the numbers. I ask myself, how many times does x plus 1 go into x squared? That's kind of too hard to answer. So instead, I ask myself, how many times does x go into x squared? In other words, what do you have to multiply x by to get x squared? You have to multiply it by x. Okay, so again, how many times does x go into x squared? It goes in x times. Whenever you find out how many times it goes into, line it up with the appropriate term of the same degree. So x is going to go right on top of 3x because they both have a power of 1. Okay, now what do I do with that x? I take that x and I multiply it times x plus 1, and I put it right underneath the polynomial I'm dividing it to. So x times x plus 1 is x squared plus 1. Okay? And now, what do I do with these two? I subtract them, just like I did with long division. So I'm going to subtract, and that just simply means that I'm going to change both of the signs. Okay? So actually, whenever you're doing this, go ahead and change both of the signs. Okay? So x squared minus x squared, those are gone. 3x minus x is 2x, so bring that down. And then I bring down the plus 5. Okay? And then again, I ask myself, how many times does x go into 2x? In other words, what do you have to multiply x by to get 2x? I have to multiply it by 2. Put a plus 2 there, because it's a positive 2. Now what do I do with that 2? I'm going to multiply the 2 times x plus 1. Okay? So 2 times x plus 1 is going to give me 2x plus 2, right? 2x plus 2. And then I'm supposed to subtract these things. So switch both of the signs. When I subtract 2x minus 2x, that's gone. 5 minus 2 gives me a remainder of 3. So labeling all the parts on this one, x plus 1 is the divisor. X squared plus 3x plus 5, that's my dividend, what I'm dividing into. X plus 2 is the quotient, and 3 is the remainder. Now, I'm not quite done with this problem because I want to write the remainder in a certain way. I want to write it as a fraction. What would that 3 go on top of? What would be on the bottom of that fraction? It would be what I divide by, x plus 1. So this is how I would write it. So the x squared plus 3x plus 5, that's what I'm dividing into, is the dividend. The x plus 1, when I divide it by, is the divisor. X plus 2 is the quotient. 3 is the remainder, goes on top of the fraction. On the bottom of the fraction is the divisor again, x plus 1. And that's how I would write my answer. Okay.